weren't supposed to relieve me.
I know, but I felt like taking a shift.
You like him, don't you? You like watching him.
Don't be ridiculous.
We're gonna kill him. You understand that?
Morpheus believes he is the one.
Do you?
It doesn't matter what I believe.
You don't, do you?
Did you hear that?
Hear what?
Are you sure this line is clean?
Yeah, of course I'm sure.
I better go.
Hello everyone, and welcome to your final assignment for CS202, Assignment 8, created by yours truly. And so, I thought I'd make it a little themed, so let's go with the theme. So, I hear you want to become an agent for the Matrix. So we here at the Matrix take our work very seriously. Anytime any exiles or hackers want to connect to the Matrix, we trace down and eliminate them. The safety of the Matrix and the machine world will be in your hands. To ensure that you are prepared, we have developed this assignment to test your call tracing skills. Whenever someone connects or jacks into the Matrix, they use the landmine, and tracing these calls quickly can be the difference between stopping a disruptor before he, disrupts us. So currently, we are looking for a hacker known by the alias of Neo. We are not sure what he is capable of, but we are making him priority one. Therefore, as part of your job interview, we will simulate doing this tracing. Do you have what it takes to be an agent? Agent Smith and others will be awaiting your results. So, don't disappoint us. Alright, so basically, this assignment, you are going to be simulating with a linked list, a sort of two-dimensional array per se, and it will be a bunch of random characters, and for that I'm going to switch over to the write-up and just kind of point things out from there. So this is what it looks like, what you're going to be making. And in one of these different fields or nodes, because each of these is a linked list node, there's going to be a 3-character string. And that 3-character string is randomly generated. However, in one of these, instead of being just a random 3-character string, is going to be your target, Neo. As you can see, if you haven't seen it already, there's our target. But that gets randomly generated, so every single time is different. And our goal is to trace. And that's all you gotta do, you gotta trace. But you gotta trace the call, you gotta trace the location, and then give it back so that the agents can handle it from there. Okay, so the assignment itself, like explaining it, is relatively straightforward. I think coding it is not too bad. It's about 200 lines of code for mine, and of those, I'm giving you like 20 lines of code, so you're probably like more like 180, and there's documentation, so it's a pretty simple assignment. I think explaining the assignment, coding the assignment are both easy. What's tricky is probably debugging the assignment, because if you're not very careful when you're coding those 200 lines of code, you can make a bug that is going to segfault your program, and it's just going to be a pain. So already there, my warning to you is you should be using a debugger to test your code and to debug your code. And if you're not, this assignment is going to prove to you that you should use one, because it's the difference between fixing a bug in 1 minute and 1 hour. Okay? So let me give you a little drawing of what this 2D list should look like, and then we can go from there. Okay? So basically, here, this is some thematic music while we're at it. So it's very quiet. Hopefully not too quiet, not too loud. But here we go. So basically, we all know a linked list from class as a one-dimensional list of nodes. And each node is connected with one pointer, right? If it's a singly linked list. Now, if it's a double linked list, then we simply add another pointer, right? So actually, there's a reason why I have this drawing like this. I might post this as a bonus video in the description, but I tried asking ChatGPT to do the assignment for me, and I failed. After an hour and a half, I gave up. It kept giving me what looked like to be a good answer, but it kept segfaulting. And even though I knew exactly where it segfaulted, I couldn't get it working. So I was like, whatever. So I guess does that mean that the assignment is ChatGPT proof? I don't know. Don't test it though. Or if you test it after the semester's over, and then you can test it and let me know. But don't do it now. Otherwise, that's cheating. Because we want you to code the assignment, right? Never send. What is the quote from Agent Smith? Never send a human to do an AI's job or a machine's job. That's it. Anyways, that's a singular linked list. Now, a doubly linked list typically has a second pointer, which we call like a previous and a next. Doesn't really matter what you call it, and it points to the node behind it, right? So that's a doubly linked list. Now, it's no fun if you just do that for the assignment, because you, like at least in my class, in my videos, I basically give you the full code for this, and you just be copy pasting the code from class and be done with the assignment. So I said, okay, what's kind of the next difficulty step in doing this? Well, let's go into 2 dimensions. In fact, I wanted to do 3 dimensions, but I thought 2 was enough. So let's go with 3 dimensions. A 3-dimensional link or 2-dimensional linked list. That means there's going to be rows and columns. So how do I modify this data structure to make it into 2 dimensions? I keep saying 3 because I wanted to do it 3, like I said, but I chose not to. So what we do is we add more pointers. We can add an up pointer like that to all our nodes. And then, I guess because we want it as a doubly link so we can go up and down, we can also add a down pointer like that. So now, from any given node, you can go up, down, left, or right. Go ahead and do that for every single node, and now everything is fully connected. So you can go back and forth however you want. So just because I don't want to have to draw this 50,000 times, let's just copy paste. Like such. And voila, there it is. So each individual node is going to contain 4 pointers. Oh, that just did not come out. 4 pointers and 1 data value. So let's just make a kind of a big picture of it. So like this. So this we're going to call right. This we're going to call left. This we're going to call up. And this we're going to call down. And make everything lowercase. Okay? Ignore the fact that I made it uppercase. And then the inside is just going to be a data. And in our case, it's going to be a string. Okay? And then these are pointers of the node type. All of them. Okay? Because this itself is a node. And so that's why I draw it with the arrows. So that is going to be one of the 2 classes you're going to be making. You're going to be making a class called node that is going to contain all those 4 pointers and that data string. The data string is just a variable. Don't make it a pointer. It wouldn't make that much of a difference, but there's no point of making it a pointer. Okay? So, yeah. The other class you're going to have in this is the linked list class. That is going to be where you basically take this node and build this 2-dimensional linked list. Now, to make it a little bit harder, when you build this linked list, you give it a dimension. So you say, length and width. In my case, the length is the vertical lines, and so think of it like number of rows, and then the width is the horizontal lines. Okay, so make sure you understand that so you don't flip it. So let's say you want to do it. What is this one? So this is actually going to be a length of 3 and a width of 5. So the function call to this would be something like, not function call, but the declaration of this object, linked list 3.5. That's what would declare something this size. Now here's the cool thing. You throw away these length and width once you first make it. So you're not allowed to have local class variables here that contain the length and width. You only use them when you build it in the constructor, and then you discard them after that. Why? Because you don't need them. You don't need to know how big a linked list is to be able to manipulate it. You can simply keep looking around using the pointers, right? You can, if you want to know how many rows there are, just use the down pointer until you get to null, right? Because every other pointer that is not pointing to anything, you want to make sure it's a null pointer, right? So yeah, that's kind of the one challenge, I suppose, you have to do. And other than that, the content of these strings is going to be randomly generated. So let's go back to the PDF so I can just kind of walk you through that. Okay, so this is just the theme part. And then this is your general explanation. And then here's your overview, right? So you have two files. You're going to be given just one of those two files, which is the main.cpp. And that file you do not need to modify, and you should not modify. In fact, I told the NT that's setting up the code grade to hopefully have that already pre-built in there. So you just have to upload the other file. I don't know if that's going to work like that, but just see what code grade asks for, okay? But if not, then just upload it. But do not modify it. Okay, main.cpp. You are being provided this file because I am going to get to that. I have some commented out code in that file that you can use for testing. So you want to play around with that file, yes, but before you submit your code, make sure you revert it to the original version to make sure that it works with that. The main reason for that is because of the function call names and things like that. Function names in general. The other file, the one that you are going to be submitting and where you're going to be writing all of your code, is the linklist.h file. So it's a header file and it just has all the code that you need is just all going to be there. Okay? So that file is not given to you. You have to write it. And what you have to write in that file is going to be the two classes, the node class that I just went over, and then this linked list class. Okay? So in that linked list class, it should contain just one pointer, which is of node type, which is going to be your head, just like a linked list would. And then everything else is just functions. Like I said, do not keep variables that contain the length and width. You're not allowed to do that. It's the one thing that I did to make it slightly harder, and because it makes you practice using the pointers as well. Also, you're not allowed to declare any form of arrays in the assignment. No arrays allowed. This is the goal of this assignment is twofold. On one hand, to familiarize you with the data structure of linked list and its capabilities and limitations, but also to get you practicing as much as possible to use pointers so that when you get to 302, you are a little bit more prepared for dealing with graphs and other things that just have pointer galore. Okay? So it's not for me just being weird that I'm limiting you to not using arrays, to not keeping the size of things. It's because it's a way to get you to practice this. And by the way, I recommend that over the summer you also keep practicing coding in general, in addition to just to this topic, okay? Because 3 months is a long time, and by the time you get to fall, especially if you end up taking 218, which is not C++, and then you take 302 in a year from now, if you don't code C++, it's not going to go well. It's not going to go well, okay? Anyways, going back to the assignment. These are the functions that you have to do. First, you have this function called RNG-string. Its purpose is that when you call the constructor to make an object of linked list, to make a linked list, it needs to randomly generate those three strings, right? Those three character strings. And so that function will do that. The only big caveat to that is that because we want to be able to grade your assignment with automation, we need to make sure that the randomness match. In other words, if you tell the computer pick a random letter, we want to make sure that it picks the same random letter that we're going to pick on our testing end. Otherwise, it will be just chaos to automate the grading because of the string matching. You could do it, like, you know, technically speaking, you could do it, but it's just too much work, I think. So to make it much easier, the main file you're getting takes as command line arguments 3 numbers, the length, the width, and then a seed for rand. And that seed is going to be the same seed that code grade is going to be inputting into your code. So by having both using the same seed, we should have the same output. Even though it's random output, it will be the same random output. Okay, so that's going to be very useful for testing and also for us grading. So because of that, anytime you call rand, you're basically asking it for a new random number. If you call it one too many times or one too few times compared to my solution, it's not going to match. You're going to be in trouble. So you have to be very careful that you only call it when I say to call it. And I'm going to go over each of those individual calls right now, starting with RNG-string. RNG-string should call rand 3 times, once for letter. So there's a 3-character string, so there's 3 letters. Each time you call rand, it's going to generate a number, and that number use modulus against the size of the alphabet from A to Z to pick what that number is. It's going to be the letter. That's going to be the first rand call, the second rand call, and the third rand call. So make sure that you have that in there just like that, and then your code will match the sample output in the text and also the sample output in code green. Okay, so that's my big caveat for ing string. It just it's a function. You ask it to give you that string, and it gives you back that string. That's all it does. Pretty simple function. The constructor is the big function in this code. You can read this and just kind of get an idea, but really all I want to point out from this is that when you're making the nodes, after you make a node, go ahead and actually call this RNG string function to insert the data component to that node, which is the random string. And so, important. This is I should read this before I say anything. So yes, what I'm saying is true, but at the beginning of the function, so you gotta pick. So remember, we gotta pick somewhere in here to put our neo, right? And we want it to be random so that we can find it. But again, it's pseudo random because we want to be able to be deterministic compared to code green. So you need to call rand twice to generate a coordinate, a length vertically and the width horizontally to pick. So for example, if neo is here, it means that this is 0, because I already start from 0. So 0, 1, and then this way it's 0, 1, 2, 3, 4. So this is technically 1, 4. 1, 2, 3, 4. Yeah, so this is 1, 4, coordinate 1, 4. So to generate that, at the beginning of the constructor, before you call rand anywhere else, just call it twice and use the past length and width that you're getting in the constructor as a parameter to the constructor. Use those to generate a length and the width that you're later on, just for now, generate the number that's going to be the spot where you're going to put neo. Okay? So now going back to actually the main loop of the constructor, when you're actually building the linked list, build it horizontally by completing a row first, getting that row done, and then build a row beneath it. Okay? Don't build vertically, because again, the randomization is not going to match. Might end up, if your sample output looks like mine, but it's a transposed matrix essentially, because this is what you're building, matrices at the end of the day. That's why Simon's called the matrix. But if they're transposed, it means that you're building it in the wrong direction. Okay? So build it horizontally, row at a time, left to right. So left to right. Okay? So as you're building it, each time call RNG string to generate that string, and then if you get to the location where you need to replace this, where you need to place the neo string, this is important. Have it generate, and this is simply because this is the way that I did it, not because it's better, but have it still generate a random string for that spot, and then replace it with the neo string. Okay? If you don't, if you say, oh, this, if you're at a piece, if before you generate the string, you have a piece of code that says this is the right coordinate, so don't generate a random string, put neo instead, your output's not going to match mine. It's going to be off by one spot. You'll see everything kind of shifted. That's a sign that you didn't do that. Okay? So really, those are the kind of things you just have to be careful about in this assignment because of code grade. Okay? Don't get me started on code grade. I wouldn't use it. I would just remove all that difficulty, but then the TA would have to spend like hours grading each one because they have to test it. So there's, that's the limitation of code grade when you're trying to do things with randomness. Okay? So again, to just make sure we get it. In your constructor, the first thing you do is generate a 2 integers, length and width, that are going to be the spot to insert neo. Use rand with modulus of the length and the width passed in. And then the next time you're going to use our rand function is going to be when you call the RNG string function, because that's going to call the function, and that is going to call it 3 times per node. Okay? I believe that's, well, there'll be more rand calls, but at least that's it for the constructor. Okay? Make sure you link everything. So, make sure all these pointers here, make sure everything is linked right. Okay, so you can go up, down, left, right, and whatnot. And that these are all null surrounding it. So make sure all of that is good to go. Next, in terms of functions, is just the structure. Just make sure you deallocate everything when you're done, when the program is done. We will test it with background, so make sure you have no memory leaks, no memory errors. Piece of cake, actually. Like, hint to you, your print function that we're going to talk about and the destructor are almost identical. However, warning, do not use dangling pointers, okay? So that's one trick that you'll see in my videos or in your instructors, that when you're deallocating even a one-dimensional linked list, you need a temporary pointer so you're not accessing technically a dangling pointer because you're accessing a node's pointer after you've deleted that node, okay? It's very easy to kind of miss that, and I think Valgrind will yell at you. And even if it doesn't, the TA will. Print function should just print to the terminal what it looks like. I'll show you some sample output in a minute here, but that's pretty much all it does. And then the cool function, and kind of cool because I mean I'm giving you half of it away, and I'm very sad about that. But it was just too complicated with the RNG stuff. Okay, so now that you have this, like, to the linked list, we want to trace and find Neo, right? So I created two modes for this function, mode 0 and mode 1. Mode 0 is a linear search. So it starts, so always, by the way, I should point this out, the head node is always going to be the top left. Top left, yeah, top left. So it's always the head, and it's always the only node that it's the only access way that you have to your linked list, okay? And so in linear modes or serial mode, it should start here, search all of this, go back to the beginning, search again, go back to the beginning, search again, and when it finishes, if it finds a success, if it doesn't find it, no success. It should always in theory find it, but you should have code to, just in case it didn't find it, okay? That's pretty much it for the linear search. The second search, which is mode 1, is kind of neat. So it's random. So you start here, and then you randomly pick a direction, whether it's up, down, left, or right, to go. And then it just keeps randomly picking until it finds it. So it's kind of neat to see how the machine does that. If it tries to go off, so as I say, it's here and tries to go up, when it sees a null pointer, it just goes back and picks in the direction again. I don't want to say it picks another direction, because all you do is you just randomly pick a direction again. So it's very possible that you keep picking up like 3 or 4 times before it picks something else, okay? Let it be like that. Don't try to optimize this version, because again, the randomness will not match my randomness, okay? See, this is very limiting because of that. So like, but that is life, okay? So yeah, because of how much of a headache that is, I gave you a function called RNG direction, where you pass it in the nodes, just a node, and it's going to return to you a pointer to the next node that you're supposed to go to, whether it's up, down, left, or right. And this is the exact order that it does it on, okay? So it's called, it basically runs rand, mod 4, because there's 4 possible directions. And then depending on whether that returns anywhere from 0 to 3, it's the direction that it picks. After it picks the direction, it needs to make sure there's not a null pointer there, so it's not falling off the map. If it isn't, then you're good. It returns that node back to the other function, to the trace the call function. If it's a null pointer, then it tries again. And the way it tries again is using recursion. I thought, you know, I didn't have to use recursion for this, but it's a nice example of recursion that's actually useful. So yeah, recursion. So, you know, I wish if I could make you all actually do this as part of your assignment, but I know it's going to be so much headaches when you if you try calling RAN in different ways or optimizing it. I was like, no. It's just like, shake my head. Plus, the RAN thing, as cool as it is, it's not really a linked list. It's just cheese on top of it. Okay? So, yeah, that's the RAN function. And so this trace the call function should call, every time it wants to pick a direction, it should just call this function. It's a class function, so just copy paste it in, slap it in there. Don't touch it, don't modify it, don't document it more than it currently is, so that it doesn't mess with the cheat detection that we have, okay? I'm supposed to just ignore this block. So, yes. Also, just because I don't want you to DDoS code grade, this whole thing, when it tries to search for it, so search for the node, should hard limit it to 10,000 searches. So if it goes over 10,000 because it's a big enough map, or just the RNG just happens to not hit the node in 10,000 tries, it should stop, so that you don't have a code running. And I think code grid does time you out after 2 minutes or something, but just in case, 10,000 is a pretty short number. It stops quickly. Okay? So yeah, that's mode 1. Okay? And that's it also for the RAN calls, I believe, as well. So let's go over main. Okay, so for that I'm actually gonna show you main in my code. So this is when I coded this. Okay. So very quickly, you have command line arguments. You have a usage case. You're supposed to pass in the length, the width, and then the seed value. I talked about already. And then you have a round call. Oh, I guess you're not thinking that this is the first ever round call that you have. It's because I'm actually activating it's actually not a round call. This is actually sround. So this is actually us using the seed value in the program. So it's seeding the randomness with the number that we pass in over the command line argument. So in theory, this says 3442. If you run this with 3441, it would be a completely different output. So you can use this for testing purposes. Okay. My recommendation to use test different places for the neo. Maybe it's on the corner, on the middle, on the first row, on the only row, just to make sure that there's no weird bugs there. This is the creation of the linked list. The first parameter being the length, the second one the width, and then you print out so that we can see what it looks like to the screen, and then tracing the call in the two modes. Mode 0 being that linear one, mode 1 being the random one, and there's technically, if you feed it a wrong mode, so like mode 5, it should give you an error as well, so just code that in to have as well. And that's it. And then the rest of the main is just commented out code. So if you're developing this, which you will be because it's the assignment, I would comment out this whole section of main and then uncomment this and work with this version. This version will help you test some edge cases that I've basically found useful when I was developing this. And by the way, if you're curious how long it took me to do this, probably like an hour and a half. It wasn't that long from zero to like code finished. So yeah, includes testing it and changing my mind on a couple of things. But yeah, so yeah, this is the code that I used to test it, to make sure it was working. So yeah, I left it in there. It could be useful for you to testing it. This code is not going to be tested on CodeGrade, this part. But like I said, I would use this to develop it, okay? And then there's linklist.h. This is your solution. This is the solution right here. You bet you're trying to zoom in, but you can't. Anyways, here's the RNG direction function in there. As you see, it's a class function. Obviously, I'm not going to show you anything else in that line of code or in that file, other than this is up here to make sure that it pulls it in. Okay, so that's it for the code. I mean, there's really not much more to say on that. I'm just going to show you how this code looks like. Okay, so compile, run, and let's just kind of see it. Okay, so here we have it. This is the same example from the PDF. And then you can see it runs trace 0. Trace 0 is successful. It found that coordinate 1, 4, which is what we were saying earlier. 0, 1, 2, 3, 4. And it also shows, so make sure you do this, you want to show how many comparisons it took to get there. Okay? So a comparison is whenever you are literally taking what is in the string and you're comparing if that is equal to neo. Okay? So let's count and make sure this is right. So when you start, because it's starting on the top left, you're going to be looking at this, right? So comparing this to the string neo. Is it equal? Yes or no? It's not. So that's one comparison. This one, 2, 3, 4, 5, 6. 6 on the first row. All right? Then we get to 7, 8, 9, 10. And then it has to compare the string neo. If that's equal to neo, that's an 11th comparison. And yes, it is equal, so you're like, I'm done. But that was technically another comparison that you have to do. So it's the 11th one. Okay? So that's how this comes to 11. By the way, something I wanted to point out here, if just so you know, as a tip that I sort of, a decision that I made when I was developing this. I generated first a one-dimensional linked list, so like a row, in one pass, and then the second pass around, I linked those pointers to the one above it. So kind of how when I was drawing it, first I created like a row. So let's just do that. So you don't have to do it this way, but this is what I found to be the quickest that require the least amount of brain power. So like I developed a row. So like, bam, I made this row, okay? And then it's the first row, so that's all you gotta do. But from the second row and on, first I created the row, bam, done, and in one for loop, and then I did another for loop beneath that where I actually link it. So where I actually start linking this and this. So that's updating two pointers. Okay? And then, you know, when I get to a third row, if there is one, I make the row in one pass, and then the second pass, then again I go and I update those 2 pointers. Okay? So just an advice. If you want to do it, you don't have to do it that way, but then you have to like think, and like I didn't want to think. I just wanted to get it done. So that's, you know, like time complexity wise, you know, 2n is still n. So yes, it would be a little bit faster to develop it if you did it all in one for loop. It would be twice as fast. But once you get to drill 2, you'll realize that it's the same n time complexity. So like whatever, you know. So anyways, just thought I'd point that out before I forgot. Going back to this, now we're going to see trace 1. So trace 1, it's very cool to see what the computer is doing if it's searching it right. Also good for debugging purposes if your number doesn't match the one that I have. And so it prints out the direction that it tries. Whether or not it goes there is a different story, but it still tried it. And it counts those, and then it returns to you how many compares it had. So for example, again, you start from here, and so this is kind of tricky. So I'll use my mouse, I guess, and my fingers. So the first time you try to go up, right? So it can't go anywhere, so it just stays there. Then it tries to go left, it can't go left. Then it tries to go right, so now it's here. Then it tries to go left, so it goes back to the beginning. It tries to go down, so it goes here. Then it tries to just go left for a bunch of times in a row. So it just stays there, basically. You can see that this is why I like it. This is why you don't want, you know, code it like me, where each time it picks a direction, it doesn't remember what the previous direction it tried. If you try to optimize that, because you're like, oh, you can't go that way, so don't do it. Which is, by the way, a way of optimizing this. But if you try to do that, you won't match mine. So make sure you do it exactly like mine. So no memory of the previous attempt. Okay. So anyways, once it sees this R, now it's going to go here, and then it's going to go left, and I have to use my finger on the screen to kind of remember where I'm at. But yeah, then we go down, so you're here, then try left twice, then right, then left, up, down, up, oh, whoa, okay, up, right, right, right. Oh, we were so close. And then it tries to go down twice, then up, then left, then down, then up like 20,000 times, and then left, then up, then right twice, then left, down twice, up, right, so close, up, right, down. There we go. All right, so I literally put my finger next to each letter so that I kept track of it. Okay, and voila, that works. So yeah, that's pretty much how it works. And let me just show you what happens if you run it without anything. So you get the thing there. Let's try running it with a big number. So let's try 9, 9. The last number, it's just a seed. It can be whatever. So this one, 61 compares. It's interesting to see the compares. So you would think that on average, this should be less than this. You know, this is like BOGO sort versus linear search. BOGO search versus linear search, I guess. But yeah, let's try a different seed number. 69 for that one. 206 for that one. You can see the big difference, right? Sometimes like, oh, that one's, oof, yeah. Oh, look at that one. That one's pretty neat. Oh, well, it's because it's almost at the top, so I guess it makes sense. I'm trying to see one case where like we might get lucky and the linear search takes longer than the random search. I did see that in one case, but it's not common. Oh, that one's kind of close. Oof. Ooh, that one's bad. Oh, come on. We might just not get lucky. Yes! There we go. This one we got lucky, just right before I gave up. The magical number was over 9,000. It was close to 1,000,000. So in that one, where's our Neo? 4, 3. So 0, 1, 2, 3, 4, 3. Here it is. So this one, it sequentially it went like this. Took 40 tries. This took 22. It seems like it went down, up, 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 right, right, left, left, back to start, up, up. Oh, so really like from here is where it actually did cool things. So really like, yeah. So let's see it. It went down, it went right, it went up, it went right, it went down, it went right, it went down twice. Oh my God, it would have been so close, but then it went left. Wait, what? But there's no down at the end. Oh, I might have screwed this up. Let's try it. Let's see. So it starts with, I gotta use the finger tactic. Okay, so down, up, up, right, right. So then it's here, left, left, back to start, up, up. Okay, so down, right, up, right, down, right, down, down, left, up, here we go, down, down, left, right, right. There we go. Okay, you use finger tactic, finger meta. Okay, so there you go. Just for the memes, let's try something big. Maybe like 30 by 50. Seed value of 1. 687, not bad. All right, let's go bigger. 300 by 500. Trace failed, there we go. Okay, so this was where like we just went hardcore. And on the linear one, it would have taken 15,000. It's a dot spot, 30,116. And here it just tried 10,000 times and it gave up. Okay, so make sure that you do that. I wish I had a line feed there. Oh well, too bad. I can't change it now because I gave it to the NT. So yeah, just match outputs and you'll be fine. So that is it. Remember, agent, you have to be able to find, you have to be able to trace the call, right? You know, we're counting on you here. So succeed at it and get hired and become an agent. Okay? So let me make sure I'm not forgetting anything else I want to point out. Nope, I think I'm good. So good luck with the assignment, and I'll see you around.
Hello?